Hi team, welcome to Wiggins Maths. In this video we will be looking at integration by parts. In essence, this is the integration equivalent of the product rule, so that is two functions multiplied together. As always, do not neglect the formula book. Okay, firstly, some good news. There it is. Integration by parts formula, directly taken from the formula book. Okay, it's all well and good that being in there, but we do need to know how to use it. So let's have a look at how we do that. So first thing we need to do is we need to look at which of the two functions we can differentiate, and importantly, which will become more simple when we do that. Sometimes it's also useful to look for what we cannot integrate, because that will determine which one we choose. Then we label them appropriately, then we substitute it into the formula, and then we tidy it up, we finish it off. Okay. So, which of these can we differentiate? Both. Which of these can we integrate? Both. But which one becomes more simple when we differentiate? That would be x. So that is going to be our u, and this is going to become our dv by dx. So let's write those down. So du by dx is 1, and v is negative cosine x. Okay, so we're nearly done. Substitute into the formula, so uv, subtract the integral of v du, so that's negative cos x, dx, because we're multiplying by 1. Tidy this up ever so slightly. So I can remove the negative here, I can take it out the integral, which makes this plus. And then we just need to finish it off. Integral of cosine x is sine x. And then of course, let's not forget our plus c. Okay, second one. Which of these can we differentiate? Both of them. Which of these can we integrate? We can integrate that, but we do not know how to integrate ln x. So that tells us that that must be u. And that is dv by dx. So let's write these down. Okay, so du by dx is 1 over x. V is x to the power 4 over 4. Nearly done. So uv is x to the 4 ln x over 4. Subtract the integral of v du, so it's x to the power 4 over 4 multiplied by 1 over x, which is that with respect to x. So one of those x terms cancels, and then let's finish it off. So x to the power 4 ln x all over 4, subtract x to the 4 over 16 plus our constant. Lovely. Okay, so this one doesn't look as if it's integration by parts. Remember, throughout these videos, we're just looking at different techniques. You will choose eventually which one you prefer to use at different points. But I can rewrite this, and it's important to recognize that we can rewrite this as sec squared. And then we can use it by parts. So which of these can we differentiate? Both, I think. Which of these can we integrate? Again, both, thanks to the formula booklet. But which of these simplify when we differentiate? Well, x does. So we'll make that u, and we'll make that dv by dx. Okay, so let's write these down. It's always better to be as methodical as possible with these. So du by dx, and v is, well, sec squared integrated, formula book. It's tan x. And then we're nearly done. So uv is x tan x, subtract the integral of v du, so that is tan x dx. So integral of tan, I'm not sure what that is, but it is in the formula book. and then add our constant. Now of course we could have turned this into sine over cosine and then used the reverse chain rule or substitution or something like that, or just look in the formula book. Okay, so this one's slightly different, I guess. So hopefully we can identify straight away that this is definitely going to be u, because e to the x does not simplify, does not become more simple, it becomes itself. So u is x squared, du by dx is 2x, dv by dx is e to the x, and v is e to the x. Chuck it in. So that's going to be x squared e to the x, subtract the integral of 2x e to the x with respect to x. Okay, so it looks as if we're going to have to use by parts again. Now, from experience, I've never seen a question where you need to do it more than twice in an exam. Now obviously in reality you can have problems where you use integration by parts multiple times, but in the exam I've only ever seen it twice, so it's worth bearing that in mind. But we do like e to the x, very, very handy. Okay, so finishing this off, x squared e to the x, subtract, now this is worth bearing in mind, it's subtract this thing by parts. So subtract uv, uv is 2x e to the x, and then it would be subtract the integral of v du, so it's going to be add the integral of v du, so that's 2 e to the x with respect to x, and then we're there. So x squared e to the x, subtract 2x e to the x plus 2 e to the x plus c. Whew. Okay, so one final example, a special case, ln x. Now this obviously doesn't look as if it's going to be integration by parts. There's only one function there, right? Now to integrate ln x you need to use by parts. Okay, and the way that we make it have two functions is we multiply it by 1. Now as we mentioned, ln x we don't know how to integrate directly, so this is going to be u, and the 1 is going to be dv by dx. And then once we know this little trick, it will work out quite nicely, as you will see. So du by dx is 1 over x, and v is x. Plug it into the formula, so it's going to be x ln x, subtract the integral of v du, so v du is x multiplied by 1 over x, which is just 1, and then finish it off, x ln x, subtract x plus our constant, and there we have it. Okay, so if you found this video useful, please subscribe, tell your peers, and I will be aiming to upload new videos each week to ensure that we are as successful as possible. And of course, remember, amateurs call it genius, masters call it practice.